Okay, so we were looking at type 2 compensator, and what we figured out that inherently your converter is unstable if you use type 2 or PI compensator. So, we need one more 0 which can be introduced by adding a ESR at the output cap. So, from here we can calculate the, we know omega UGB, we know omega naught, KU0 is known, and if we design your OTA for a certain GM, let us say 1 milliampere per volt, then RP can be calculated. And so, let us take an example. So, C equal to 10 microfarad. RESR, I think we calculated some 0.5. That we, let's, so omega naught what else, VDD, okay. So, ESR 0 we are considering at omega naught, and from there we can calculate. So, FSW is, let us assume 1 megahertz. So, F of UGB is usually kept FSW by 10, which is 100 kilohertz. Omega UGB is 2 pi into 100 kilohertz. Okay, 628. So, your RP is omega UGB, which is 2 pi into 10 power 5 over omega naught. How much was omega naught? We calculated. Do you remember? 0.127? 17? 174. Okay. Then KU0. So, KU0 is your beta. Beta is half into VDD, how much? 1.8 over 1. Okay. And GM. So, GM I am considering 1 milliamp per volt. Okay. So, how much is RP? So, this is 0.9. Two pi, so 10 power minus 3, 3 goes up, so into 10 power 2, 0.174 into 0.9. Okay. How much is 4.01 or 4 kilo ohm? Can you just check if it's correct? So, okay. So, 10 power 5, 3 goes up, 10 power 2, 0.174. Okay. So, 4 kilo ohm So, this was your type 1, we want to convert it to type 2. So, values we are taking this 1 milli, okay, and so before we add this, we want to look at the uncompensated response. So, let us do this. Okay, so I am not putting compensator here, I want to just look at uncompensated. And what should be the gain? Uncompensated, you have only Ku0 and that will be shaped with your L and C. Okay. So, let us see what we get. $900 milli. So, we had beta half, okay, and now at omega UGB, which was 100K, what is the gain? Gain is 72 milli, which means the total gain we require 1 over 72 milli. So, how much is that? 1 divided by 0.07, 14.2 roughly. Okay. So, 14.2 means GMR out should be, or GMR of this, I want to shift this whole thing to 14.2 times, correct, which means 0.9 into 14.2, you will get. So, I think the values we are getting there, it's not correct actually, because GMR, that means should be 14K roughly, 14K, huh? What happened? Oh, you need to connect this, huh? Okay, so now you are getting a gain 1 at 100K. So, which means your proportional gain GMR should be 14.2. So, RP should be 14.2, not 4K. So, I think we did some mistake. So, let us go back here, omega UGB. Okay. So, I think the reason we are getting less here, because we are considering the effect of gain due to 0 also. Okay. So, see, if this factor is not there, omega UGB or omega naught, then you will have only this one. So, your RP will be different in that case. Okay. So, right now we are not considering that 0. So, now let us see if I put the, so in order to have that 0, we need to have that capacitor. Okay. So, value should be, so based on this 14.2, if I let us say calculate the value of C, how much will that will be? Omega naught is known 174 kiloradian, and you are placing that 0 at omega naught, correct. So, from there you can calculate this Ci. Yeah? So, 1 divided by 174 kiloradian divided by 14.2. What value you considered, 14.2 or 4?
14 point, I am getting 0.4.
Hmm?
It's 14, I am getting
0.4 what?
nano.
0.4 nano, huh? So, this is a problem with the simulator. If you have a capacitor hanging, then it will not simulate. So, it looks for a resistive path here. So, you can add this some gigaohm. Okay. So, the value you calculated was coming around 4K. It's only one zero, huh? That we are not adding second zero, right? What did we consider the first zero? Omega naught or omega naught by 2? Omega naught by 2. Then this cap should be double, huh? Okay. Probe. So, it's 100K. Okay. So, now if I add the second 0, what would happen? So, in this we are not considering the effect of 0, the ESR 0, and if we are not having, so value we require is 4.2K. But if you take the effect, then value we calculated was 4K around. So, which means if I make it, it was some 0.5 ohm roughly, okay. Then my UJB should shift at higher frequency because my gain is increasing. Zero dB you are getting 300K, and if I make it 4K, that's pretty close to 100K. Okay, so that means that value is correct if you consider the effect of second 0. Okay. Now let us look at the phase response. So 100K we know, we can close this, and we have to look at the phase at 100K. So more than 60 degrees. Now if I do not have this, let us say I make it again back to 10 milli. You can see your phase is going below 0. Okay, so in this region you can say there is no phase margin. Okay. So that's how you calculate your values, parameters. So one important thing is whenever you calculate the proportional gain, and if you have a second 0, so you have to consider the gain effect, because without that 0 your resonance, due to resonance your gain was falling by square, but the moment you add one more 0, that becomes first order, and that is why your gain requirement changes, or your proportional gain requirement changes because of that. Okay. So, still this, if you look at the value, this 800 pico is not small, huge to integrate on chip. Usually we look for less than 100 picofarad or so. So, which means you have to reduce the GM. Okay, if I reduce the GM, then I can increase the value of R to get the same gain, and I can reduce the capacitor. So, let us say I make 100 micro this. So, this will become 40K and this will become 80 picofarad. So, let us see if we get the same thing with that. 100 micro, 80 pico, 40K. Let's put it back, 0.5. Okay. So, your EGB remains same, and let us look at phase response. You still get 63. So, this is not changing anything, your location of 0 remains same, your proportional gain remains same, only difference is you are changing the GM, and we already talked about if you reduce the GM what happens, offset problem. Okay. So, this is the drawback with this GMC compensator, because the GM, I mean if I want to reduce the cap value, then I have to reduce the GM, which means we may have some offset issues with this, or other way, if I want to increase the GM, then my capacitor requirement will be large and it will take lot of area. So, what we do? We go with op amp RC. Okay. So, let us first summarize this. So, type 2 compensator requires one more 0 which can be added by okay. Therefore, op amp RC Okay, but that doesn't mean we don't use GM. You can use GM still. If let's say with 100 micro ampere per volt you can achieve the offset you are getting, it's within your spec, then you can go for it, that's not a problem. Okay.